Hello everyone. Today we will solve some examples about hypothesis testing. So the first exercise is here. Let's read it. So from generation to generation, the mean age when smokers first start to smoke varies. However, the standard deviation of the age remains constant and around 2.1 years. A survey of 40 smokers of this generation was done to see if the mean starting age is 19 or not. The sample mean was 18.1 with a sample standard deviation of 1.3. Test the hypothesis under 10% significance level. So, in order to understand if any question is hypothesis question or not, you can just see here. So it says that test the hypothesis under 10% significance level. So okay, this is a hypothesis testing question, and the first thing you need to do is just write down what is given. Okay, for example, we have 2.1 in here, 40 in here. Let's write this down, 2.1 and 40, and also we have 19, so let me write 19 here. So we have 18.1 and we have 1.3 and we have 10%. So if we know what these values are, then we can solve the question with no doubt. Okay, so the first thing is 2.1. So what is 2.1? So we can understand from the question. It's a standard deviation, but which standard deviation it is? So is it standard deviation of the sample or standard deviation of the population? So we can understand that it says that the standard deviation of the age remains constant all the time. So it's a standard deviation that belongs to a previous knowledge. So because of that, that standard deviation belongs to the population, not the sample. Okay, so it is a sigma. It is very important to understand this because the whole question, the solution of the question will change because of this. Okay. So how about 40? 40 is our sample size. And what is 19? So we will come back to 19 later. Let's first write 18.1. It is the sample mean, which you already know. It is x bar. And sample standard deviation, which is here, actually s. So what is significance level? Actually, it is the alpha. Okay. So we wrote down what is given, but we have only 19 here left. So after this step, we will write down what 19 is later. So let me just clear in here. And the second step is construct the hypothesis. Let's construct the hypothesis. So my suggestion is constructing the hypothesis. You need to start from the claim, which is H1. So first we need to write down H1. But first we need to decide which population parameter do we test. Okay. So what is the test is about? So I think it is about mean starting age. As you can see, mean starting age is 19 or not. Okay, so actually it's a hypothesis about mean, which means, let me write down it. We will just test the population mean, which is mu. So it says that it is test the hypothesis that the mean is 19 or not, which is we will test the hypothesis 19 or not. So how about these equality signs in here? So how can I decide it? So as a just small note, equalities always lie in H0. So whatever you do, you should put the equality in H0, which is the original hypothesis. And the rest of it should lie in the claim, alternative. Okay, hypothesis or claim. Okay, so we constructed the hypothesis, but in here, so what is 19? What is 19 in here? So we name it as mu 0. Okay, we will use it later. So mu 0 is 19. Okay, now we constructed the hypothesis and we need to solve it. How can we solve it? So as we can see in the hypothesis, it is a two-sided because we have equality. Okay, so we need to test the hypothesis in both sides, but we need to decide on the test statistics. The next step is deciding on the test statistics. So we need to test it with some value. Okay, so how can I decide? So you can check from the formula sheet as you have. So for mu, we have two questions. First, sigma square is known or unknown, and if it is known, we have a formula. If it is unknown, we have another question, which is if n is greater than 30 or n is less than 30. Okay, so we have three different formulas in here. So what is in this question, what is the case? So the first question is sigma square is known or unknown. So as you can see in here, it is known. So we have the test statistics. Test statistic is actually ZH is equal to x bar minus mu 0 over sigma over square root of n. So we use this formula. So let's use it with this. We know everything about the test statistic. X bar is 18.1 minus 19 over 2.1 square root of n square root of 40. So we don't use this because we don't need it, because we already have population parameter. So let's solve it. So when we solve this question, it is minus 2.71. So how can I decide about the hypothesis by using this test statistics? Of course, you need to use the significance level. So we need to first draw the graph, and it is z. And since it is two-sided, so we need to use both sides. We need to use alpha over 2. So here is alpha over 2, here is alpha over 2. What is alpha over 2? It is actually 0.05. 0.05. So here is 0.45. So we know this value 0.45, actually it is 1.645, and we have also here minus 1.645. So we need to just compare our test statistic by using these values. So these regions with the blue is called rejection regions. So if any of our test statistic falls into this region, then we can say that the hypothesis can be rejected. So let's look at our value. It is minus 2.71, and we can see that this value falls into this area because it is somewhere here. So which means it falls into the rejection region. So let me write this. So ZH is equal to minus 2.71 is smaller than minus 1.645, which is Z alpha over 2 actually. So because of this, we can decide that H0 is rejected. Why? Because it's in the rejection region. When a value is in rejection region, we reject the null hypothesis, the original hypothesis. So the decision is reject the H0. Okay. So what is the comment about it? What does this mean? This means that under 10% significance level, we have enough evidence to say that the mean age is not 19 for smokers actually. Okay, so the question is done, but we can solve the same question by using confidence intervals. So how? Let's open another sheet. So we know that sigma is 2.1, we know that x bar is 18.1, we know that what else do we know? N is equal to 40, so alpha is equal to 0.10. So since we know this, the confidence interval formula of this x bar minus z alpha over 2 times sigma over square root of n is less than mu, our population mean, x bar plus z alpha over 2 sigma over square root of n, so which is this formula. So if we put these values in the formula, so we have already found it, times 2.1 over square root of 40 mu, say 18.1 plus this. So if we solve this question, the results will be this. So our confidence interval is this. So how can we understand about the hypothesis? So our mu0 is 19. So if 19 or mu0 is in between the lower bound and upper bound, we cannot reject H0. But as you can see, 19 is not between these values. Therefore, the same result, reject H0. Okay, so the same result is valid like here when you use the confidence interval formula. So this exercise ends in here. Thank you for listening.